Universally unique lexicographically sortable identifier. UUID can be suboptimal for many use cases because it isn't the most character-efficient way of encoding 128 bits of randomness. UUID v1 v2 is impractical in many environments as it requires access to a unique, stable MAC address. UUID v3 v5 requires a unique seed and produces randomly distributed IDs, which can cause fragmentation in many data structures. UUID v4 provides no other information than randomness, which can cause fragmentation in many data structures. Instead, herein is proposed ULID ulid /01ARZ4RFQ69G5FAV 128-bit compatibility with UUID 1.8 plus 24 unique ulids per millisecond. Lexicographically sortable, canonically encoded as a 26-character string, as opposed to the 36-character UUID, uses Crockford's base 32 for better efficiency and readability, 5 bits per character. Case insensitive. No special characters, URL safe. Monotonic sort order correctly detects and handles the same millisecond. Implementations in other languages, from ourselves and the community. Language author binary implementation C++, Suyash, C#, MCB 2001, Clojure Thequila, Objective-C, Ricardo Pereira, Crystal Superpaintman, Dart Isos, Dart Gapardo Apps, Delphi Matinaso, Danxi D, Dub Extraworst, Erlang Savonarola, Elixir Home Polish, Elixir Merongivian, Elixir Omisego, Elixir Ecto, D. Cuddeback, F# Lucas Shetman, Factor Alexander Ilin, Gooklog, Haskell Steven 77, Java Zam, Java Lewis Cowles 1986, JavaScript Aron Cohen, Julia Arslan Kotlin, Gopardo Apps, Luataisky.net, Rob3.net Filers, Nemadulk Ocamel Stripe Pajamas, Perl 5Pay, PHP Lewis Cowles 1986, PHP Robin VVV Luton, PowerShell, Peter Bomben, Python M. DePiero, Python a Hawker, Python M. Dom, Kaiser B. Armster, Ruby Rafael Sales, Rust May Stoyu, Rust Dylan Hart, Scala Petit Violet, SQL Microsoft Armulator, Swift Simon Whitehouse, Swiftius Lab, TCL Do Dan. Specification below is the current specification of ULID as implemented in ulid JavaScript. Note, the binary format has not been implemented in JavaScript as of yet. 01AN07BY, 79A1 Theos and SR9X4MV3. Timestamp randomness 48 bits, 80 bits. Components. Timestamp 48-bit integer Unix time in milliseconds won't run out of space till the year 10889 AD. Randomness 80 bits. Cryptographically secure source of randomness if possible. Sorting. The leftmost character must be sorted first and the rightmost character sorted last, lexical order. The default ASCII character set must be used. Within the same millisecond, sort order is not guaranteed. Canonical string representation, where T is timestamp 10 characters, R is randomness, 16 characters. Encoding. Crockford's base 32 is used as shown. This alphabet excludes the letters I, L, O, and U to avoid confusion and abuse. 0, 1, 2, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, G, J, K, M, P, W, Q, X, Y, Z. Monotonicity. When generating a ULID within the same millisecond, we can provide some guarantees regarding sort order. Namely, if the same millisecond is detected, the random component is incremented by 1 bit in the least significant bit position with carrying. For example, import monotonic factory from ulid const ulid monotonic factory. Assume that these calls occur within the same millisecond. Ulid, no 01bx5z kb 8k m 9b m 0. If, in the extremely unlikely event that you manage to generate more than 280 ulides within the same millisecond, or cause the random component to overflow with less, the generation will fail. Import monotonic factory from ulid const ulid equals monotonic factory. Assume that these calls occur within the same millisecond. 1 BV KGP being VR ulid 1 BX 5 BX 5 9 9 and then I have JPK 9 of ulid 01 BX 5 CV9 VVEMVS1 ulid BX ZKKX your lex ulid 01 BX5 KBX throw new error overflow errors when parsing base 32 stri.